Hello, I'm Miro Blaško, and today I would like to do a small session about practical debugging of SPARQL queries using algebra or transition of query syntax to algebra. You all know SPARQL, so I won't take too much time here. SPARQL query has many parts, where part. I will be talking about select SPARQL queries only for today. And there are some parts which are called in specification, for example, basic pattern, like triple pattern here you can see, or here is the filter, here is some union operator, here is optional clause, I think it's called. And they all mean something different. I would point out that there is also this parentheses, which indicates some group patterns. So if you have basic pattern like person is person, and person has age, then if you put it into parentheses, you create group pattern of having two basic patterns. Also, one note here, you can have even empty group pattern. So if you would remove everything between where parentheses, and if you would remove everything from here, you would get actual result, and you would return one row of containing unbound variables of person and image. So if you would remove the content of where, this is called empty group pattern, and I will reference to that later. So here is an example query which I believe could ask for person that has age that at least 18 years old. So well, at least 19, because here is not equals. So at least 19 years old. And this person cannot have siblings that are from different country than Slovakia. So cannot have siblings outside of Slovakia. And we also retrieve image of that person, but only as optional, so it might not exist and it might not be bound at the result of the query. The query returns, as you probably know, some rows, and those rows can repeat. In specification, I believe they call it multiset. So it's not set, but evidently you can repeat elements. And the multiset, it's because it is not ordered, but of course in SPARQL you have operators for ordering, so you can order it as well. And you basically, what you retrieve, those rows that I was talking about, I believe this is called solution binding. Yeah, so that's about queries at the beginning. I would like to create some some smaller example as a motivating. So let's say we have data, Alice is a person, has image, and Bob is a person. And we would like to evaluate only such a simple query as you can see there. So there is we want to retrieve every person and its image somehow. So maybe I would like to ask you here what this query returns. if you could think of, and we will get later to it. And how we gonna process or evaluate this query? We will first translate the query to the algebra, and then we infer from that the result. So we will not execute it on the SPARQL engine, but rather we explain how it works through query algebra. This is quite useful to use query algebra, because sometimes we don't remember how it exactly works, and there are some tools that take query, put it into query algebra, and then you can easily find in specification what operators within algebra means, so you can really execute it yourself as an engine. Query algebra has many operators. I would explain some of them. So for example, this is often used for basic graph patterns. So join operator, it just takes mapping from one set and combined it with another set, and only return compatible mapping. Then another operator is left join, which I hope you know from databases, and it's that you have set M1 and you attach set M2 and return only compatible mappings where M2 is compatible with M1. So you just attach the triples or those patterns from M2. And this operator has also the condition, so you can also filter some of those triples by condition. I will show it later. So this is just overview of some of those, or I would say those most important operators, and let's go further. To translate query to algebra, here is some simplified algorithm that I found from this resource. You can have a look later. And we will use this algorithm to translate the query. I took very similar query. Basically, it's variant of the other query. This is what is in between where clause, and this is how what it returns. But I just wanted to show slide where both of those pictures are together. So I would go over this transformation algorithm. So within the transformation algorithm, you have this on the input, and you would like to translate it to the algebra. First, what you do is you replace all basic graph pattern with BGP. So here you can see person is a person. So here is this BGP. Then here you can see person has brother sibling. Here is BGP, person has brother sibling. Then the other step is you replace all patterns of the form P union Q. So here it is, union, BGP, BGP, and here is parentheses, and here should be closing. Yeah, closing parentheses. So you replace this part with union. And then you start from innermost sequence of expressions. So yeah, SPARQL allows nested expressions. So here you see nested expressions, and you start from innermost. And what you do is you remove all filter expressions and store them combined in conjunction. What is it? Phi. Yeah. So you store them in conjunctions. So yeah. So here is filter expression. So country is different from Slovakia. So if you would have different filter expression within this optional part, you could combine it. So we would say country isn't from Slovakia and whatever filter is it. It does not depend whether this filter is at the beginning or at the end of this group part, or I mean of this optional section. So filter is not dependent on order. Because at the end you just combined it together with AND. But there is no example of that, but you can see that this filter is here. Then initialize result to be empty SPARQL expression Z. So as I said, empty group patterns actually returns empty result set. So this is exactly what you do. Into the result, you put empty SPARQL expression. So you have basically table that match any other table there in R, and then you go. If you find optional with filter, you create left join R, so the result, so this empty table, A is all this, so union together with sibling lives in country, and you add the condition from filter here. So you can see left join, union, and union and sorry. There is this join. I forgot about join. Basic patterns are combined together through join. Also, you see here union, so you combine it through join, and then you left join person, what's inside of the optional, and you take those filters and you put it here. So again, you put this basic pattern here. This is this R. Then you put out whatever is in optional pattern beside filters, and you put those filters here. The conditions from filters here. So yes, I hope it is clear. If optional doesn't have any filter, you just put true here. Otherwise, you use join. So that's why I forgot to show this. So that's it. That's how you translate it to algebra. And if you understand those operators, it should be easy to understand what will be the output of the query. So for example, here we have this simple motivating example. So we want to execute we had this query there, but I would like to show that those queries actually return different results, although which might be for many people counterintuitive, because I would say that here is a person that optionally have an image, and somebody would think that this would return same result, but it's not true. What we'll do is that we do automatic translation. I will show it later online on using website. And when we translate this, we would get, we start, sorry. Yes. So we start with this basic pattern, then we add it here and put it into left join. So this means that to the table containing person, we just attach image. But here it's different, because we start with optional and we join this empty table. Here it is called table unit. So this empty group pattern, as I said, and we attach to that table this basic pattern, and then we attach this person of type person. So the result will be following. While this query returns what everybody would expect, this is something that could be for somebody confusing, because it first bound to person, and only those persons that were bound with image were tested for being of type person. So this is how it works. And basically that's it. I have here some complex examples and how they translate in this online tool. And it would be nice to, so if you have time, it would be nice if you go over it and try to find out whether they really mean the same or not, using the algebra and going to SPARQL specification, where it is specified what those operators mean. You could mathematically prove yourself that they are same or not. So here are some variants of this query. I put here I, instead of union, I use property path. Here I used just another group pattern, another level, another nesting, I would say. So that's it. And I will show you how to play with this translation. So you have web page, SPARQL.org, query validator, and here you just put your query and you click on include SPARQL Algebra, and it shows you this this algebra as I showed on the picture. There is I was not talking about this project operator which just take its projection and those other operators that are important for prefixes and stuff like that. So this is how you can play with it. let's try this. Here is this table unit that I was talking about. And also you can put the other query that is more complex to see how it translates. Yeah, maybe this is interesting. Filter not exist. You could see that filter basically always answer true or false. So it's all in the filter, the result of the subquery, when you combine it with left join here. So yeah, that's it. You have, I included link to translation to SPARQL Algebra within SPARQL specification and the SPARQL Algebra itself. And also I included link to some lecture from where I took 2 screens, and there is also video, which I'm not sure if it's the same lecture, but there are some slides that I was showing there, so you can find more information there. So that's it. Thank you very much, and